Okay, so you guys have already studied parabolas, but only one form of them, a quadratic function. So a quadratic function is also a parabola. The quadratic function only opens up and down. But today we're going to look at parabolas that open up, down, left, and right. Now, we're going to talk about the conic definition, the geometric definition of a parabola. And that is that it is the set of all points in a plane. See the parabola here? So that's an infinite number of points in this plane that are equidistant from a given point, called the focus, and a line called the directrix. So do you see this point right here on the parabola? Is 8.08 and 8.08. It's equidistant from both the focus and this line called the directrix. Now watch as I move it. Do you see these distances are still the same? As I move it, the distances are still the same. As I move it, and I throw it down here at the vertex, the distances are still the same. They're the same, 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 they're always the same. Alright, is everybody watching? Mm-hmm. You love math.
They're the same.
You love math. Math is fun. Okay, you're not even looking. I'm trying to hypnotize you. Come on. Alright, Cole's in. Alright.
I'll always
So
hypnotized.
that's the definition. So we talked about two things. Okay, you've got to be quiet or you'll get thrown out of the classroom today. It'll be, I'll mean it in a loving manner, but it may not come out that way. Okay, so this fixed point, we call it the focus. So we've been dealing with focus and foci all unit. And this line is called the directrix. More weird names in math. So, what I'd like you to do is copy down this definition. It's the one I just said a minute ago, a parabola. The geometric definition is a set of all points in a plane. They're equidistant. What does the word equidistant mean?
They're both the same distance
Very
from
good.
a point.
Oh, look, SAT word. From a fixed point called the focus and a line called the directrix.
It actually wasn't on the SAT.
That's good, because they only have one version of the SAT. So you should take that same one over and over again.
Wait, they don't change the version?
I am messing with Hayes.
People do that a lot. But
Well,
I
it's
just
because
play
you're a
along
smart butt to people all the time.
with it.
So
I am not.
you request for people to treat you in that way.
Alright, Cole, you are probably the pettiest person listening.
Alright, you're taking notes.
Cole, that's what baseball fans to school.
Yeah, that's what baseball fans to school.
You lost our
Hopefully
freshman
those dress
year.
codes like. I'm gonna go to Leonard today.
It's a pair of pants.
I'm gonna tell Leonard how to dress code. Oh, that's how I'm gonna do it.
See, he's so petty.
They are dress code.
How are they dress code?
So no, they're not. Girls.
They're not dress code, they're pants.
They are dress code. He'll be fine then. Yeah, you'll have to wear them. If you lost a bet. Sorry, bud. Man of your
Yeah,
word.
make a man up.
I'm gonna wear them. You wouldn't wear them.
I would wear them. Why do you always say
Hayes
that?
wouldn't wear
Hayes
them.
would-
I
What was
would
the
wear
bet,
them.
Cole?
And I would rock
It
them
came in
too.
last in our March Madness bracket.
I would wear some
You're
cowboy
always
boots and baseball pants.
I was.
It's
I
not
was-
over yet.
I was first
No, I'm
for a
done.
long time till Kentucky
You
lost
got 'em all
yesterday.
wrong.
Alright,
Yeah, I know that.
and here we go, because everybody's had plenty of time to copy that
Feel
down.
like 7.
Alright,
No.
now, this first one, you are familiar with this version because this is vertex form. You know how to graph every parabola that opens up or down that is in vertex form. So, we know how to find the vertex, HK. We know what A does. It affects our moves. We know the normal moves for a parabola. 1 squared is 1, 2 squared is 4, 3 squared is 9. So, you are welcome to graph them that way. I'm going to show you another way that I think is easier, but you are welcome to graph them the way we've already learned. Now, you do have to understand the definition of things we're talking about though, because we're talking about parabolas and not quadratic functions. We're talking about them in terms of the focus and the directrix. So if our parabola opens up like this, we obviously have a positive A. If it opens down like this, we have a negative A. So what's new is the one that's open left or right. So So when we look at those, instead of y equals, what do they start with? X equals. The center is still HK, but we have to be careful. The y is always with the y. So if it's grouped here, it's right here. And what's added to the end is the x. So you just have to make sure you're just not moving along too quickly and make this your x and that's your y. Okay? Alright, so these are going to open left to right. If A is positive, it'll open right. If A is negative, it'll open left. Now, when we were talking about it's a set of all points in a plane that are equidistant, that distance from the vertex to the focus, that distance is called P, or from the vertex to the directrix. That distance we named P.
P, because if you turn P upside down, it's a D, and D equals distance.
Okay, that works. Alright, so whether it's in this form, y equals, where it opens up or down, or in this form, x equals, where it opens left or right, the vertex is still the same. It's HK. Well, in this form, the opposite of that is our H, this is our K. But in the x equals, the opposite of this is our K, and this is our H. Okay, now P, we just discussed, is the distance from the vertex to the focus, or from the vertex to the directrix. They're the same. That's P. Now, how do we find P? Because P is important to be able to find your focus and directrix. P is actually equal to 1 over 4A. Bless you.
Thank you.
Now, the directrix is just that imaginary line that is P units away from the vertex. And it's part of that definition. Because we formed a parabola because it's a set of all points in a plane that are equidistant from a focus and a directrix. Okay, so let me sketch this bottom part again. And then real quick, we'll talk about an easier way to graph. Okay, so if we had the vertex here and the focus here, we know it's P units apart. This distance and this distance always have to be the same. Well, this distance is P and P, which makes it 2P. So this distance is 2P. If we go directly left and right from a parabola that opens up and down, or directly up and down from a parabola that opens left or right, we can double P, and that gives us 2 points on the parabola, and this is a new way we can graph it. Now we can also go back and use the moves. If you're happy with the moves, and you're good with them, stick that way. Now this distance all the way across is called focal width.
4P.
And it ends up being 4P, yeah. That is the width of the parabola at the focus.
Where did that come from? Focus. Number 4.
I could write it, but you wouldn't like
Math.
it. It's ugly. But you can just memorize it.
Yeah, I'm fine with that.
Okay, so we're going to start with one that's just like what we used to do. It's a y equals, and the first thing, this is your thought process. It's best to visualize it. Is this one going to open up or down, left or right? How do you know? It's going to open up. It is y equals and A is positive, so it's going to open up. Now, just like every
What's
focus.
A, the 1/2?
Yeah, the 1/2. Every foci of any conate is always inside the conate. So if it's an ellipse, they're inside. If it's a hyperbola, they're actually inside, right? If it's a parabola, the focus is inside. So we know the focus has to be here, so the directrix has to be down here. So we kind of know before we ever graph it what it should look like. General idea. So where is the vertex of this particular parabola?
Negative
-2,
-1.
-1. That's where we'll start. -2, -1. Now, I'm going to show you how to graph this by finding P. Because we need that to get the focus and directrix anyway.
P is
So
distance.
P is the distance from the vertex to the focus. So if we know that, we know where to plot the focus. It is 1/4A. So what is A in this problem?
1/2.
1/2. And half of 4 is 2. So P is 1/2. So
Is P A or
we're
is
going
it
to
just lucky on
plot
this problem?
P now. P is not always A.
Okay, so it's just
Okay, so it's 1/2, and we know we have to go up to get there, so we're going to go up 1/2. So what's up 1/2 from -1?
0.5.
Yeah, -0.5. Good. Good.
so we are
Now, one way of graphing is to double that P. Double P. So if P is 1/2, if we double 1/2, what do we get? 1. We get a whole. So from this, right here at, it's hard to graph exactly where it is. If we go over 1 this way and over 1 that way, that'll give us 2 points on our parabola, and we can sketch it.
what is that?
If you double P and you go that distance in either direction from the
What is
focus,
that finding?
it gives you 2 more points on the parabola, and you can sketch it.
How do you find
Now,
a line on the bottom?
okay, P was 1/2, so if we go up 1/2,
We
it
go
gives
down
us the
1/2.
focus. But if we go down 1/2, it'll give us the directrix. That is a crooked directrix. That's better. Okay, so we went down 1/2 from -1, so it's going to be y equals -1.5 because we went down 1/2. And the directrix, you're going to notice every time that if this is y equals, the directrix is y equals. All right, now, let's say you don't like graphing it by doubling P. That's fine. You can still do the moves. Plus or minus 1 squared is 1. Plus or minus 2 squared is 4. Plus or minus 3 squared is 9. But because this one has the 1/2 in front, we would have to multiply by 1/2. So we would go over 1 up 1/2. Oh, look, we already have a point there and there. That was part of our focal width, wasn't it? If we go over 2, we go up 2. Over 2, up 2. Oh, look, that's where it was anyway. So you see, whether you graph it by doubling P and getting the focal, the entire focal width here and sketching the graph, or if you use moves, like we used to, you're fine. Yes, sir.
The top part of the graph doesn't have to be exactly right, does it?
What I'm going to look for to be correct on these graphs to get full credit is this point has to be right, this point has to be right, this point has to be right, the focus has to be right, and the directrix has to be right.
And to start off, it's 1/2. So how did you get -2, 1? Did you just
How'd I get the
Oh.
vertex?
Yeah.
You take
Uh,
the inside number and the outside number.
The vertex comes from up here. The opposite of this is your x, and that's your y.
Oh, okay.
Okay? Now,
Wait, how'd you get the focus again? Sorry. How'd you get the -2?
Because it's the opposite of the x.
You
Never mind,
didn't
never mind.
shift left or right.
Okay.
Okay. So this one, it's x equals, and it's an understood +1.
So that means it's opens left or right.
Okay? And because it's positive, it's going to open right. Okay, so here's our idea. We know it opens right. We know this has to be inside, and this has to be back here. So it looks something like that.
So the y is +3 and the x is 1.
Very good. The y is +3, the x is 1. All right, so let's graph it. 1, 3, boom.
All right.
Now, that's step 1, vertex. Step 2 is find your p. P
inferring
is
is
1 over 4 times A. A is an understood 1. Very good. So P is 1/4. So that means if I go over a 4th, see we already drew, the focus has to be inside here. If I go over a 4th,
Inside.
over a 4th from here would add a 4th to the 1. So it'd be 1.25 because a 4th is 0.25. 1.25.
Why'd you add it to the x? Oh, because it's not going up and down. Never
Yes.
mind. I keep on asking that.
Could I also put 1 plus 1/4 to the third, or 1 plus 1/4, comma 3?
You could put 1 and a 4th, but if they can't add,
I
we
gotta
should.
get my books.
Can we take our stuff?
Yeah, we have 2 minutes left.
Yeah.